Here we have AP calculus AB problem. Okay, let's go to the question. If the point negative 1 comma 5 is a point of inflection of the curve y equals to x cube positive ax square positive bx negative 2, what is the value of a positive b? Okay, first let's understand what is point of inflection. Okay, now for example, let me consider the graph of a particular function. So here we have concave down, here we have concave up. Let's consider a point between them. So let's say there is a point over here. At this point, the curve changes from concave down to concave up. Let me consider another example. Just a moment. Okay, here there is a curve again. So here we have concave up and here we have concave down. At somewhere else over here, at a particular point over here, the curve changes from concave up to concave down. So the point at where the curve changes from either concave up to concave down or concave down to concave, that is, it's the curve changes its concavity. So that point is called a point of inflection. Anyways, we have the point of inflection on the curve over here. Since negative 1 comma 5 is a point of inflection of this curve, so this point must be on this curve. Since we have this point, this a point of inflection is on the curve, we can plug in this x coordinate negative 1 for x over here, here and here, and the y coordinate 5 for y over here. Okay, let me do it. Then I'm getting 5 equals to negative 1 to the third power positive a times and negative 1 to the second power positive b times negative 1 negative 2. Okay, 5 equals to the evaluation of this negative 1 to the third power is negative 1 positive a times the evaluation of this negative 1 to the second power is just 1, and positive times negative is negative b negative 2. Then I'm getting 5 equals to negative 1 a times 1 is a negative b negative 2. Then I'm getting 5 equals to, now we can keep this positive a and negative b as it is. We can combine this negative 1 and negative 2. Then I'm getting a negative b. So combining this negative 1 and negative 2, I'm getting negative 3. Okay, let me add 3 to both sides. When I add 3 to both sides, this negative 3 positive 3 will cancel out. On the left side, I'm getting 8 equals to, on the right side, we have a negative b. Okay, we can consider this one as equation number 1. Usually, if I want to get point of inflection for a curve, what I have to do is I have to find the second derivative critical number from the equation of the curve. So for that, first we have to do the find the second derivative, second order derivative of the equation of the given curve. Okay, let me do it. Let me take the equation of the curve as it is. That is y equals to x to the third power positive a x square positive bx negative 2. Okay, now let me find the first derivative, that is y prime. So y prime equals to 3x square, and a is a constant. We can keep this constant as it is. When I find derivative of this x square, it will be 2x. Positive b is a constant. When I find derivative of this x, it will become 1. And negative, the derivative of this constant is 0. Then let's do some simplification. 3x square, a times 2x will be positive 2ax, and b times 1 is positive b. Okay, now I got the first derivative. Now let's find the second derivative, that is y double prime. Okay, let me do it. 3 is a constant. We can keep this constant as it is. When I find derivative of this x square, I am getting 2x positive 2a times, it's a 2a is a constant, and we can keep the constant as it is. And I find derivative of this x, it will become 1 positive. The b is a constant. The derivative of this constant b is 0. Then the second order derivative, that is y double prime equals to 3 times 2x is 6x positive 2a. Okay, now I got the second order derivative for the equation of the curve. So now to get the second order derivative critical number, so I have to identify the value of x, if any, for which the second derivative becomes undefined. Actually, the result of the second derivative is not a rational function. If it is a rational function, there is a chance for some value of x, the second derivative will become undefined. For example, if I have something like x negative 2 or something like that, when I plug in x equals to 2, the second derivative becomes undefined, because the denominator will become 0. But here, the result of the second derivative is not a rational function, so there is no value of x for which the second derivative will become undefined. Okay, now this is a first method to get the second derivative critical number. The second method is we have to equate this second order derivative to 0 and solve for x. So when I equate this one to 0 and solve for x, let me do it. 6x positive 2a equals to 0. When I subtract 2a from both sides, I'm getting 6x equals to negative 2a. Let me divide both sides by 6, then I'm getting 6x divided by 6 equals to negative 2a divided by 6. So 6 will cancel. I'm getting x equals to 2 goes into 2 1 times, 2 goes into 6 3 times. I am getting negative a divided by 3. Okay, when I equate the second derivative to 0, I got x equals to negative a over 3. Actually, this is a second order derivative critical number, and also at this value of x, we have a point of inflection for this curve. That is at x equals to negative a over 3, we have a point of inflection for this curve. Y equals to x cube positive, x square positive, x negative 2. But already we have the point of inflection. At this point of inflection, the x coordinate is negative 1. So this negative a over 3 represents the x coordinate of the point of inflection. In the given point of inflection, the x coordinate is negative 1. So this negative 1, this negative a over 3, both of them represent the same stuff. That is the x coordinate of the point of inflection. Since both of them represent negative over 3 and negative 1 represent the same stuff, we can equate them and solve for a. Let me do it. So we know that negative a over 3 is the x coordinate at the point of inflection. But here in the given point of inflection, we got negative 1. Okay, now what we can do is we can multiply both sides of this equation by negative 3 to get out this negative sign and this denominator 3. Let me do it. So then I'm getting negative 3 times negative 1. So here 3 will cancel. Negative times negative will become positive, positive a. Negative 3 times negative 1 will become positive 3. Okay, now I got the value of a equals to 3. Okay, to get the value of this expression a positive b, we need the value of b. For that, we have to plug in this 3 for a over here in this first equation. Okay, let me do it. So in the first equation, 8 equals to 3 negative b. Let me subtract 3 from both sides. So then we get 8 negative 3 is 5. Here 3 and negative 3 will cancel. I'm getting negative b. Let's multiply both sides by negative 1 to get the negative sign over here. Let me do it. Then negative 1 times 5 will be negative 5 and negative 1 times negative b will be positive b. Okay, I got the value of b as well. B is negative 5. Okay, now let's find the value of a positive b. So here the value of a is 3 and the value of b is negative 5. 3 negative 5 equals to negative 2. Okay, now I got the value of this expression a positive b. Its value is negative 2. We find negative 2 in answer choice A. The correct answer choice for this question is A.